Hi students, welcome to the App Master School Foundation program. Today we are going to deal the very important topic related to units and measurements. So we would like to accept the problems in units and dimensions for the 6th class students. Let's have a look. Yeah. Problems, units and measurements, you can take that. This is very important, you have to know that. So while you are going to have the concept of measurement of volume, you have to consider that three-dimensional space, all right? Yeah, you need to know about that. Just you have to take this one, that is yes, if you are going to take the measurements, you have to see that. So that measurements along 1D, 1D and 2D and 3D, it's okay. While you are considering that distance, displacement, all right, it's very clear, we would like to get this one. So you are all going to have that look into that matter. Area, yes, it is very clear, we would like to know about this one. Sometimes we need to calculate that area, sometimes we go for that volume, that is in 3D. You have to take that parameters. It's very clear, we would like to go for this one, that is volume. This is a three-dimensional concept, just we have to take that. While you are going to measure the density, you have to take that volume. Simply you can take that, you are taking that density is equal to mass by volume. Just you have to consider. All right, have you seen that density is going to be related to the volume? If you are identifying that solid and gases and liquids, all they are going to have that calculation of their density. Sometimes you need to know about that volume of the container, because that liquids, they doesn't have that any particular shape, they are having the shape of the container, all right. Gases also, they are going to have that, all right. Now you can take that, this is very clear. While you are going to get that volume, yes, you have to get that shape of the container, shape that is going to be taken, all right. We have to consider, this is a one, we are going to look into that matter. Let's have a look. Yes, measurement of volume. Yes, you have to take that, what we have discussed with that, you need to take that, it's very clear. This is a one concept which is going to be solved. Yes, you have to take that matter. Yeah, you need to get that solid, liquid, and you need to get that gases, solid, liquid and gas. You need to take that. So all these are going to have that shape of container. And you need to get the measurement. Yes, you have to take that volume of container. Just you have to take that. Yeah, they are going to be measuring. Yes, you have to take this one. Let's assume cylinder, its volume is going to be measured. It is very important. You need to go this one, right? And if you are going to get this one, atoms, matter is going to be, it is the composition of the atoms. So you will get that properties. If you want to estimate that microscopic properties, you need to study about that atom, all right. So atom, which is going to be spherical, all right. So you need to know about that sphere. Yeah, you have to study, yes. In order to estimate the properties of the atom, just you have to get that sphere volume. You need to consider that sphere volume, all right. It's very easy for you to solve the problems related to that volume measurements. What is the need? If you are going to take that atoms, they are going to transmit that energy, all right. The microscopic phenomena which is responsible for that macroscopic changes. The best example, you have to get that expansion of solids and transmission of heat and thermal conductivity. All these are about from atoms, from the microscopic particles. You have to study this one. Sphere, just you have to take that. It's very clear, you need to know about that. Let's have the deep discussion, all right. Yes, atom is in spherical shape. In order to find out the volume of atom, we have to consider the sphere, all right. It's clear? Okay, let's have a look. Yes, volume of regular bodies, just you have to take that. This is going to be volume of sphere, it's going to be taken, yes. You have to take that. Just cylinder, just you have to take that, where r is the radius of cylinder, r is the radius of cylinder. It's very clear. We would like to go for this one. Generally, if you are going to take that atom radius, yes, in angstrom units, that is nothing but angstrom units, all right. You are going to know about this one. This is very easy for you to know that the radius of atom can be measured in terms of angstrom units. You know very well about that. 1 angstrom unit, it's going to be 10 to the power of minus 10 meter. Just you have to follow this one and substitute in this one. N number of atoms, how many number of atoms are there, just you have to consider. From that concept you can have that the density of the substance, just you have to take that. If you are going to take that mercury, it is going to have that density, high amount of density. At the same time, if you are going to know about that volume of cylinder, just you have to consider 4/3, it is a formula, just we have to consider. Volume of cylinder, just you have to know about this, that is pi r square h, all right. Let's have discussion, okay. Let's go for this one. That is, if you are going to take that cylinder, all right, you have to find out that this one. This is very clear. We would like to go for this one, right. You have to take that r is the radius, yes. So you need to know about that r and you need to know about that h. Yes. Yes, this is very clear. You want to find out that volume. So, yeah, the area of the top layer, just you have to take that, this area, this is going to be area, its area is pi r square. If the area is going to be multiplied with the volume, just you have to take that, yes, volume of cylinder, volume is equal to you have to write down, that is very important. Area of the base, just you have to area of the top layer or whatever it may be, is going to be multiplied with the height. Alright, you have to take this one. That is going to be taken that pi r square into h. So, it is going to be pi r square h. You have to take this one. This is the case we can get that. You can do the problems, it is not a tough task for you if you know that all these concepts. It is very clear, we have discussed about that cylinder. Generally, we are going to take that the gas and liquid materials are going to be filled up the area and the space. Yeah, it is very clear. Now, you would like to have the discussion regarding to the volume of the cone. We have to get that concept of the cone. It is very clear. We would like to go for that. Yes. Alright. Now, it is easy for you. You have to understood this one. Top area is going to be multiplied with the height of the cylinder. That gives the total volume. It is very clear. Now, we would like to go for this cone. Yeah. It is going to be taken. Yes. Yeah, you have to take that. So, you are going to get this one. Easily you will find out that h be the height. Now, its volume is going to be known as 1 by 3 pi r square h. Just you have to take that pi r square h, it is going to be the volume of cylinder. Just 1/3 of the volume of the cylinder if the h is the same height of the cylinder and the cone. Just you have to confirm, it is very clear for you. So, 1/3 of that volume of cylinder. Just you have to take that. If h, yeah, you have to take that. This is going to be taken. H and H, just you have to take that. This is very clear, we would like to know that. So, 1/3 of volume of cylinder, just you have to get that pi r square, it is going pi r square h and it is going to be 1 by 3, it is very clear. If r is going to be taken, this is r is the radius. Yes, you can take that r and h, they are going to be same. Alright, you are going to know about this one, easily you will find out that. Now, it is easy for you to remember easily and you never forget that matter. Alright, we would like to go for that one. H is a slant height, just you have to take. Yes, if you are going to take that, this is a one problem, you have to take that. If the radius of a sphere is doubled, then the density of the sphere is dash times of its original value. It is very clear, if the radius of a sphere is doubled, then the density of the sphere dash times that of its original volume. Let us have a look. Yeah, we have to take this one. Alright, it is very clear, we would like to go for this one. We can use this space. Alright. You would like to go for the density. First you have to write down density, that is equal to mass by volume. Alright, you can take that. In the given problem, mass is going to be same, no doubt at all. Alright. They have given if the radius is going to be doubled, that is the condition, right. Okay, let us go for that. Yeah, the case is going to be sphere, you know, volume. Yeah, volume of sphere is equal to just you have to write down, that is, you can get that just you are all going to get that volume of sphere is going to be 4 by 3 pi r cube. It is very clear. All right. So m is going to be constant. Mass is going to be constant. In bracket, mass is constant. Okay, it's very clear. Yeah, you can take that. Yes. Yeah, you know, density, original density, just you have to get that. You can easily solve that. First we would like to get the original density. It's very clear. Yeah, that is going to be density, original density is going to be taken. That is going to be d1, that is equal to m by, yes, v1, right, m by v. Okay, it's better to go for that, m1 by v1. It's going to be same. Therefore, this is the first equation. Let us assume, yeah. So we would like to go for this one. V1 is equal to volume of sphere. That is going to be 4 by 3 pi r cube. So d1 is going to be having that value, that is m1 by 4 by 3 pi r cube. It's very clear. We would like to get this one, right. Next one, if you are going to identify that, if the radius is going to be taken is doubled, at the time you need to find out. Okay, you can take that radius is doubled. So you can take that case 1, this is case 2. All right, it's very clear. We would like to go for this one. Yes, we are having that. Okay. Yeah. We would like to go for this one. Case 2. Radius is doubled. That is, r dash is going to be having that 2r. All right, we are going to consider this one. Here density, yes, new density, that is going to be identified. Therefore density when radius is doubled, it's very clear. We would like to go for this one, right. Therefore d2 is equal to m, yes, we would like to take that, m is going to be constant, it's going to be m. In both the cases we would like to go for same, that is going to be m only. All right, we would like to go for that v2. All right, therefore you can have that v2 is equal to 4 by 3 it's very clear. We would like to go for the calculation of that volume, yeah, right, that is 4 by 3 pi into 2r cube. Therefore 4 by 3 into pi into 8r cube. It's very clear. We would like to, therefore d2 is equal to, up to now it is clear. We would like to go for this one. What about that d2? You have to substitute this one, m by 32 pi r cube by 3. All right, it is very clear. We would like to go for this one. This is equation number 2, this is equation number 3, this is equation number 4. All right, let's have the calculation part that is going to be calculated. Yes, we would like to go for this one. Yes, after knowing all these values, just you can go for this one. That is therefore d1 by d2 is equal to, just you have to write down, it's very clear, that is, yeah, you have to take this one, m is going to be constant, it's very clear everyone. Yeah, you have to take that, just m divided by 4 by 3 pi r cube whole upon, you have to take that. Just you have to take this one, m by 32 by 3 pi r cube. It's very clear. You would like to go for this one. After getting that all values, you can have the cancellation and you will get the ratio. That's better. All right. So you have that cancellation because the mass is going to be same. You can get the cancellation. No issue at all. Now, if you are going to get this one, all right, it's very clear. Yes, what you have identified this one, just you have to get this one, right. Now, it's very clear, we would like to go for this one. Yeah, the density of the sphere is dash times that of its original value. You have to get that. You have to find out this one, right. This is going to be identified like that. d1 by d2 is equal to, finally what you are having, that is going to be 8. Okay, so from that concept it's going to be yes, you have to get this one. Therefore, d2 is equal to 1 by 8 into d. It's very clear, we would like to go for this concept. Yeah. Yes, you can take that original value. How many times does it going to have that original value? Yes, 1 by 8 times. Generally, if you are going to get that, as the radius increases, what happened in that case, density, volume increases, but the density is going to be decreases. It is very clear, we would like to get this value, right. Volume increases. Yes, you are all going to get this one. Yeah. Finally, what you are going to have that, please note this point, this is very important. If you are knowing that the volume increases, what happened? Density is going to be, if you are going to take the density, it is going to be inversely varies with volume. Volume is going to be increases, what happened? Density is going to be decreases, say sir, no, just you have to take that. Simple concept you have to understand. If you are going to take that limited space, if more number of people are there, less number of people, just you have to take the balloon also, what the density is going to be varies. You have been blown the air into the balloon, how its size is going to be changes, how its volume is going to be increases. As the volume increases, how does it will affect the density? You have to find out. This is the case, we can identify that. All right. So, here you can get that the d2 is going to be the density of the, they are asking you the density of the sphere when its radius is going to be doubled, that is very clear. When the density is going to, when that d2 has been taken, it is going to be changing like 1 by 8 times. Easily you can understand that. Yeah. That is going to be 8 here. You can get that finally 8. So, you can find out that if you want to write down that d1 is equal to d2 is equal to, just you have to write down d1 by, just you can get this, you can write down d2 by d1 is equal to 1 by 8, just you have to get this. So you can write down d2 is equal to 1 by 8 times of d1, it's very clear what they are going to ask you, easily you can find out that. So 1 by 8 times, it's very clear. You would like to solve this problem with the help of this simple concept. But what happened if you have taken the different materials, density is going to be depending on that number of atoms are presented in that area, unit volume. If you have taken that unit volume, the number of atoms present in that unit volume has been considered, that is very important. If you are going to take that mercury, how it's going to show the difference in the density. In the less space, more number of atoms are occupied, then it gives that high density, all right. Okay, let's go for that. If you want to take that screenshot, just you can, all right. Let's go for another one. Yeah, here also it is related to the density, all right. So they have given, yeah, we can use this space, right. Okay, what they are asking you, density of a substance is in CGS system, in CGS system, just we have to take that, yeah, in CGS system, this is very clear. You would like to get this one, just you have to take this one, density of substance in CGS system is 5 gram per centimeter cube, all right, it's very clear. Its density in SI system, it is very clear, we would like to go for that system of units, already we have discussed about that CGS system, just we have to take that CGS and SI system. Yes, you have to take that, this is the modified system of SI, MKS system, modified system of MKS. Yes, you can take that. After 1971, they are going to take that common domain, that's going to be SI system. They are going to be adopting that 7 base quantities to develop that international system of standard units. They are going to be taken, that is SI system is nothing but modified form of MK system, it's very clear. We would like to, they have given you 5 grams per centimeter cube, right. So if you are going to get that in MK system, just you have to take that in kg, yes, you have to take that, you have to get that meter, it's very clear. So you know 1 gram, yes, 10 to the power of minus 3 kg in 10 to the power of minus 2 centimeter whole cube. You have to find out this, that is you have to get that 10 power minus 3 by 10 to the power of minus 6 kg per, please write down, it's very clear, we would like to get that, all right, we are about to get that, yes, meter cube. Just you have to take that, it's going to be taken as that 5 into, just you have to take, that is 5 into 10 power 3 kg per meter cube. This is the answer, just you have to take. Yes, you can take that, first one is going to be the correct answer. We can solve the problems, no issue at all. Okay students, we would like to take this. This is the answer. We have to discuss that more number of problems in the coming classes. Thank you very much. Have a nice day.